Lecture 2, naming compounds when the first element is a metal, otherwise known as a cation. They have a positive charge. Okay. All right. There are certain elements on the periodic table which can only have one charge. These are located as for metals in group 1, which has a +1, group 2, +2, group 3, which is boron, aluminum, and gallium, with a +3. We also know that there are, which these three things, these are cations, these are metals, where group 5 through 7 are negative. These are anions. They have negative charge. Okay. There are only other three elements which form a specific charge. You must memorize these. They form no pattern. Zinc +2, cadmium +2, silver +1. Must know. Okay? Now, to name these compounds that has any of the above metals, simply name the metal first. Metals are always first. And then they name the non-metal and changing the ending of the second element to "ide." In some compounds, the second half is a negative ion, which we call a polyatomic. We just simply name it. We do not use prefixes. Okay, first compound. This first compound that I see, I look on my periodic table and I see Ag. I look for that symbol. It's located in the middle, about the middle of the periodic table. Ag is silver. It has a +1 charge. And when you cover up the second half, cover up the metal, and you can see I have Cl. Cl is an element. Therefore, I name this element, change the ending to "ide." This is chloride. Second compound. Na is sodium. This is group 1. Has a single charge, cation, metal. Anything to the left of the zigzag line is a metal. Cover up this Na. I see S. S is a non-metal because you can't have two metals together because opposites attract, sames repel. So S is sulfur. Change the ending to sulfide. Last compound here, I have Ca. Ca is calcium. When I cover up the calcium, I see I. I is the anion. It is a negative element, negative charged element, and it's iodine. Change the ending to iodide. These are binary compounds. 2 elements. Okay? All right. Now, if we look to the other side, I can look first, I can notice that these are not binary. These have more than 2 elements. Therefore, polyatomics are used. And these are found on a chart. That you've been given. We do not use a comprehensive chart. That's kind of like overkill. We use certain ones. We do not need all of them. So, same process. I'm going to look at the first element. This metal, K is a metal, and I look him up on the periodic table. He is potassium. And when I cover up the K, I see that I have PO4. Since there's more than 2 elements, this is my anion. My negative portion of this compound, and I need to look it up. And when I do, I see its name. Or is phosphate. It has its own special name. We don't have to dream it up. It's what it is. So this is potassium phosphate. Second compound, Ba, barium. I cover up the Ba. I see I have OH, hydroxide. This is one of the few that ends in "ide," but it has a special name. OH is hydroxide. Last one, aluminum. Cover up the aluminum, the cation, and SO4. I see that this whole compound has more than 3 or more than 2, therefore polyatomic. That's my clue. SO4, I look it up on my chart, and this is sulfate. Remember, cations, metals, positive charge, and are written first. Anions are non-metals or polys and are second. Okay. Now this was going from a chemical formula to a chemical name. These compounds that we are naming are ionic. This has to do with the type of bond that's formed. This has to do with electrical charges, and remember, opposites attract. And these charges, the combination of the number of each has to add up to 0. They have to be neutral. Have to add up to 0. The first thing we do is we write down the element symbol. We look to see if we look for charges, and we make them add up to 0 by using the process called criss-cross, where superscripts cross and become subscripts. Okay, all right, let's look at the next examples. So, first thing I need to know is I see sodium. Sodium is in the first position, therefore I know it's a metal. It is a cation, and I look it up and I see its symbol is Na. And noticing that it's in group 1, we have been told and shown that this has a 1+ charge. We have not discussed why. We are just going with it, going with this information. The second element, I see that it ends in "ide, therefore this is an element." That's a clue. And chloride is chlorine, which is Cl. And looking at its column charge, its family, it's a -1. And I said that superscripts cross and become subscripts. So this one goes here, and this one goes here. They lose the positive and the negative, and we just use the numbers. Ones are not written. When you write the symbol, indicates that you have one of those atoms. So the final answer for this compound is NaCl. When you write these compounds, the first letter of an element is capitalized. If it has any others, it is lowercase. So you know when you find a new capital, you have a new element. Next compound, magnesium bromide. Magnesium, when I look in the periodic table, it's in group 2, Mg. It has a +2 charge. It always has a +2 charge. Bromide tells me that's also an element. So bromide is element symbol Br with a -1. Using the process of crisscross, this one comes over. This superscript becomes a subscript of magnesium. The 2 from magnesium becomes a subscript of bromine. So if I look at the total charges, 1 times a +2 is a +2. 2 times a -2 is a -2. Therefore, a +2 and a -2 equals 0. This compound is neutral. My final answer is MgBr2. Next compound, potassium. Potassium is in the first slot, therefore it's a cation, therefore it's a metal. I'm going to look it up in the periodic table. I have a K is 1+ because it's in group 1. Nitride, element, nitride goes to nitrogen. Nitrogen has a -3 charge. When we crisscross, the 3 from nitrogen becomes the subscript of potassium, and the 1 from potassium becomes the subscript of nitrogen. Therefore, crossing the superscripts to now become subscripts, I see 3 times a +1 is a +3, a -3 times 1 is a -3. This compound is also equal to 0. Therefore, my final compound is K3N. All right, let's move on. So, same process, crisscross. I have metals. I always use crisscross with metals. They can be in combination with an element or a polyatomic. So, if it's an element, it ends in "ide." There are other clues that tell me it's polyatomic based on the ending of their anion name. So the first thing I look at is the first word. The first word tells me it's a cation. That means it's a metal. It's located to the left of the zigzag line. And I see Zn. We said this earlier that zinc has a +2 charge. There are no other options. I look at the second word and I see the word phosphate. This ending 8 tells me it's my clue to a polyatomic ion. I need to look on the chart. You look around and there's on this chart, you will see that this is in the third column of a -3. Its symbol is PO4. Okay, so with this, we also use crisscross. Anytime we have a metal with an element or a polyatomic, superscripts become subscripts. This -3 of phosphate will become the subscript of zinc, where the 2 from zinc will become the subscript of phosphate. Now, because there's more than one, I must put parentheses around that polyatomic. These are bonded together. They're acting like a single unit, pretending to be, if you want to say, an element, but they're not. They're made of more than one, hence the name polyatomic. And then I can check to see if everything is good. 3 times plus 2 is plus 6. 2 times minus 3 is a minus 6. This compound total charges adds up to 0. Therefore, my final answer is ZN3 parentheses PO4 2. Crisscross. Next example, silver. Ag plus 1 has a single charge. Sulfate, there's that ending again. So I look on the periodic table. It's in the center column. I see that it is SO4 minus 2. The 2 becomes the subscript of silver, and the 1 becomes the subscript of sulfate, saying I need 1 sulfate for every 2 silvers. And I'll just put that to indicate 2 times a plus 1 is plus 2, 2 times a minus, or minus 2 times 1 is a minus 2. Therefore, this is neutral. So my chemical formula is Ag2SO4. I do not need parentheses around the SO4 because I only require 1. It's when I require more than 1 of the polyatomic, I need to put parentheses around it. Last one, cadmium, Cd plus 2. When I look at nitrate, there's a clue. I look on my polyatomic chart. I see nitrate is NO3 minus 1. I also see nitrite, NO2. We have to be very careful about the ending so that you do not write the wrong one. Crisscross, this 1 from nitrate crosses over, saying I need 1 cadmium. This 2 is more than 1, therefore I need parentheses, and I'm going to put that 2 outside. 1 times a plus 2 is plus 2. 1 times a minus 2 is a minus 2, equaling 0. Therefore, CdNO3 2 is my final answer. When I write my final answer, I do not have charges in them. Note, most of the time, not all, there are a few polyatomics that end in "ide." You have to be careful. They are hydroxide, peroxide, cyanide. Normally we do not use amide or azide. We just listed them there so that you know that they are on your chart, but they're not commonly used in our course. You need to make sure you look at these. They don't look like elements. You can't find them on the periodic table. So if you can't find them, you need to flip it over and look on your polyatomic chart. And I just want to remind you that reading the names and the symbols is very important. I'm going to give you a few examples. SR, SRO. SR on the periodic table is strontium. I see when I cover up the metal that the O is oxygen. Therefore, it's binary. I change its ending to oxide. SrOH2. Making sure, now this one I can see it has more than 3 elements, therefore I have a polyatomic. Sr is still strontium. Cover up the Sr, OH. Looking on my polyatomic chart is hydroxide. It has its own name. Other examples, I have Ca, NO3, 2. Ca, my metal, my cation is calcium. I just write its name down. Don't need anything special because I know his charge. And then I see that because this has more than 2 elements, the anion, which is the NO3, is a polyatomic. I look it up on the chart. This is nitrate. CaNO2. Now, you can see from the one above, the oxygen here is 3. This one is 2. Must be very careful when you read this. This is also calcium. And when I look up NO2, this is nitrite. Difference in the number of oxygens. And finally, the last one is Ca3N. Okay, when I look at this one, excuse me, let me push it up just a smidgen. So Ca is calcium. And when I cover it up, I see I have N, which is 1 element. This is nitrogen, goes to nitride. You can see that these endings change. So when you are given the chemical name, you have to be very careful in interpreting to go into chemical formulas. Going both ways. The 3's, the 2's, all of this makes a difference. Thank you. This is the end of this lecture.